Welcome back, guys. This is question 5.50 and the statement of this question is find the probability that a person flipping a coin gets A, the third head on the seventh flip, B, the first head on the fourth flip. Okay, so in this question we will not only solve this question, but we will also try to understand the difference between the negative binomial probability and geometric distribution as well. So this is what the first part is related to the negative binomial distribution. Okay, while this part B of this question is related to the geometric distribution or geometric probability distribution. Okay, so let us solve them. So first of all, let me solve part A of my question. In part A, the third head on the seventh flip means the coin has been flipping and the person has flipped it 7 times, and on the 7th flip he has got third head. Okay, so therefore let me again illustrate it with the help of this diagram. So it has 1, 2, 3, 4, 5, 6 and 7 slots. Okay, and in this slot, this is the 7th slot here, this is the 7th slot here, and here we have got our third head. Okay, so let me call it H3. Okay, so H1 and H2 will be somehow here. So we have H1, H2 here in all these 6. Let me represent them with this. So these are the remaining 6 slots. In these 6 slots, we will have 2 heads and also T1, T2, T3 and T4 tails. Okay, so here what would we get in order to get the 3 heads and 4 tails? The answer we will get here would be 0.5 raised to the power 3 for these 3 heads because of H1 multiplied by H2 multiplied by H3. Okay, their probabilities. Okay, let me represent them with P of H1, P of H2, P of H3. So multiplying them, we will get here 0.5, and also for the tails, we will have here P of T1, T2, T3 and T4. So we would get here 0.5 raised to the power 4. Okay, more concisely, here we can write it like P of H1 multiplied by P of H2 multiplied by P of H3. Okay, so it will be what? It will be here. It will be here because 0.5, 0.5, 0.5, and also here for this one, P of T1, P of T2, P of T3, and P of T4. Okay, these would be here, and taking them now, multiplying them together, and here we will get this one. Okay, so this is for this specific combination here. Now in order to find different combinations for H1, H2, T1, T2, T3 and T4, because this third will remain here, so therefore in order to write it here for all of them, we will have the total number of items here are 1, 2, 3, 4, 5, 6. Okay, so out of 6 we have to take the combinations with which this H1 and H2 makes with them, so it is 6, choose 2. Okay, so let me solve them. So it would be 6 factorial divided by the 4 factorial multiplied by 2 factorial, and it would be 0.5 raised to the power 7. Okay, so ultimately the answer of it would be 0.117. Okay, and that is what? That is basically the solution of part A of my question. Okay, so all of this is related to the negative binomial distribution, because this is the formula for the negative binomial distribution which we have seen now. Now, in order to discuss part B of my question, the first hat on the fourth flip. Okay, so therefore let me move down somehow. Okay, so here what we can do, the first hat on the fourth flip means we will have here 4 slots. Okay, and in this 4 slot we will get what? Here we will get the first hat, while all the others will be tails, T2, T3. Means these are basically the successions until and unless we get this heads, which is basically the success. So the number of trials or number of flips until and unless we will get heads or the success is basically represents the geometric probability distribution, and the probability of it would be what? It would be, this is probability of T1 multiplied by the probability of T2 multiplied by the probability of T3. Okay, so these are basically the failures or the tails, and the success we call to the head. This is here P of H1. So therefore it would be 0.5 multiplied by 0.5 multiplied by 0.5. This would be 0.5 raised to power 3, and multiplying it with the probability of H1, and let me call it 0.5 as well, and it is what? It is basically 0.5 raised to the power 4, and this is what? This is basically the solution of question 5.50 part B. Okay, so in this question or in this part we have discussed what? We have discussed the geometric probability distribution, which is basically the goal of my question, in which I have to discuss the difference between binomial probability and geometric probability distribution. So that's it for today, in which we have discussed that negative binomial distribution basically we get when the number of successes are available in all the trials, but we have certain number of successes and we want to identify that a certain number of success has been occurred at some trial, while in the geometric probability distribution we will do the trials and unless and until we will get the success or the required outcome. So that's it for today. If you have any question, you can ask me in comment box. See you soon.